Welcome to this video on the topic of vectors. In this lesson, we're going to learn about the parallel relationship and how it applies to vectors. Parallel vectors are vectors that point in either the same or the opposite directions. Parallel vectors are scalar multiples of one another. So, looking at this definition down here, suppose we have vector u and vector v. These two vectors are said to be parallel if vector u is a scalar multiple of vector v, where the scalar multiple k is a real number and it's non-zero. So the symbols we have here are the parallel symbol, scalar multiple, k is a real number as in it's not complex, so a negative square root, and non-zero. So once more, vectors u and v are parallel if vector u is a scalar multiple of vector v. The k could also be on the u as well, it doesn't matter which side. Where k is a real number and it's non-zero. Now let's have a look at how we can use this property to determine whether two vectors are parallel or not. Let's go to example 1. Example 1. Show that vector a and vector b are parallel, where vector a is defined as negative 3i plus 8j, and vector b is defined as 9i minus 24j. Now the way in which we can determine whether they are parallel or not is by using this property up here. So the vectors will be parallel if this condition applies here. So let's start off. If a is parallel to b, then a will be a scalar multiple of b, where scalar multiple k is a real number and it's non-zero. Alright, working with what we have here. A happens to be a scalar multiple of b. Writing this out with the values in, I will convert both of the vectors into component vector form, and we'll have negative 3 on the left and 8, and k times 9, negative 24 on the right. Okay. Now what I'm going to do is I'm going to bring the k inside of the vector on the right, which gives me the following. That's at this point I have a choice. I can either choose to work with the x coordinates at the top, or I can do the y coordinates over here. I'm going to choose to do the top ones. It doesn't make a difference in this example, so I can build an equation that says minus 3 equals 9k. And because this is my equation, I can deduce that k must be equal to negative 1 over 3. So my argument here is if these are parallel, then my scalar multiple k must be equal to negative 1/3. Now, to be able to show that it's parallel, I need to show that this applies to both cases. So what I'm going to say is that I have 8 equals negative 24k. And what I need to do is I need to show that the left hand side equals the right hand side. So working from this, I'm going to say right hand side equals negative 24k, but k equals negative 1/3. Subbing this in, we can see that the right hand side equals 8. Therefore, the left hand side and the right hand side are equal. Therefore, a and b are parallel. So that's our first example. Show that vectors a and b are parallel. The way in which we do this is we use the parallel property up here where the vectors are going to be scalar multiples of one another. You simply build a statement stating one vector is the scalar multiple of the other. You then determine the value of k to make either the x or the y values a scalar multiple of the other, and then you just verify. You verify to make sure it works with the other direction of the vector, and then if it works out, then you can conclude that they're parallel. Let's look at a different example. Example 2. For what value of m are vectors c and d parallel given that vector c is 5, 7, vector d is 15, m? So this is for what value of m. So we can assume that these vectors are going to be parallel. Given that vectors C and D are parallel, then C is going to be a scalar multiple of D, where the scalar multiple K is both a real number and non-zero. Working our way down, we build our statement. So this is our statement here. Let's expand so that K enters the vector. So we have the vector on the left must be equal to the vector on the right. Now I can build two equations from this, but only one of them is the logical starting point. If I build the first equation, 5 equals 15k, that's got one unknown, and 7 equals km, that's got two unknowns. So I'll start off with the one unknown. So my first equation is 5 equals 15k. Therefore, I know that k is going to be, this will be 5 over 15, so 1 over 3. So this is our first value. Next, we look at our second equation, 7 equals km, where we know that k is equal to 1/3. Therefore, the value of m is going to be 3 times 7, and that will give us 21. Hence, we discovered that vectors C and D are parallel when the value of m equals 21. So, to go back to what we did here, in example 2, what we were doing was we were saying for what value of m, vectors C and D will be parallel. Where vector C was purely numerical, vector D had one of its components with a value of m. Now, because it's asking for what value they are parallel, we suppose that both vectors C and D happen to be parallel by default. From there, we build our statement that vector C has to be a scalar multiple of D, and therefore we can build the equation C equals KD. From there, we simply solve our first equation, which is 5 equals 15k, to discover what value of k will make these vectors parallel. From there, we can use that value of k to solve the second equation. So that's our second equation. This is our first. Solve our second equation to therefore deduce the value of m. In this case, it's 21. Therefore, we discover that vectors C and D are parallel when m equals 21. Sometimes they won't be parallel, but in this example they are. So, in summary, what we had a look at in this video was vector parallelism, where we discovered that vectors are parallel when they point in either the same or the opposite directions. Similarly, parallel vectors happen to be scalar multiples of one another. So using that concept there, we can build this definition here. Using this definition, we can either show that vectors are parallel by simply showing that the statement is true, or we can determine values of unknown vectors simply by using the property as shown before.